Hello everyone, welcome. So today I will be helping you with arithmetic and geometric sequences. So arithmetic sequences are sequences that stretch on forever, like this. And each one of its terms differs by a constant value. So things like 1, 2, 3, 4, and so on are arithmetic equations because the common difference between these are all 1. So that means the distance between the first term and the second term and the third term, the third term and the fourth term, and so on, are all exactly the same. And in this case, that common difference is 1. So that would be what we would have as our common difference, or the value that stays constant whenever we are trying to find new values for the sequence. So these values never change throughout the sequence, which stretches on to infinite amount of terms. It goes by this equation. So it's just the previous term plus the common difference. So this one and this one. Here, I'll put this as a D instead of a C. So this is just the formula for finding a, I guess I should put these in parentheses. So this is just the formula for finding an arithmetic term, an arithmetic sequence term for the next one. And this right here, like I said before, is a term beforehand. So in this case, if we wanted to find the fifth term here, we would have to plug in the last term, which is the fourth term, which is given here, which is 4. So 4 minus, which is 4 here. I'll just do it like that. So this is the place of the term, and so this is 4. This is the fifth term. This is the fourth term. So this one we don't know, but this one we know it's 4. So fourth term plus, okay, this is plus or minus, but we can also have minus here, but this is plus in this case, so we'll just have plus 1 since that is the common difference. So then we would just solve this, and this equals 5, which would be our fifth term. And then that would just be our final answer for that question when finding the next amount of terms. So let's move on to geometric sequences, which, here, I guess I should put this over here, this over here. So this geometric sequences are slightly different than arithmetic sequences, but they still have sort of key points here. So like this, we also have a common, sort of like a common difference, but in this case it's the common factor. So we would have to multiply the common factor by the previous term. So this is n minus 1 times the common factor, which I'll just put as f. So this here would just be what we would use to find the next term for a geometric sequence. So a geometric sequence is also a sequence that stretches on to infinity. And these, infinite terms, not infinity, but sooner or later when it gets into the very high places, like maybe the millionth place or something like that, it would classify as a large enough number to be called infinity, but we won't be getting to exactly those numbers today. But let's just start with a common one, which is, let's do 5 times 5, 25, 125, 600, here, let me see, 625, and so on. So this term, this one, we would have this as 5 as the first term, and the common difference, the common factor here would be 25 divided by 5, which is 5, and that is pretty much staying constant throughout this entire, that is staying constant throughout this entire sequence. And if we wanted to find the fifth term here, we would have to plug in the last term here, which is 625, times the common factor, which we just solved, equals 5. So 625 times 5. So that's 3,000 times plus 125. So that would just be 3,125. So that would just be the next term here. So that would just be the fifth term. And that is pretty much all that is for arithmetic and geometric terms, but there is another type of sequence here as well, and that is sequences that don't classify as either of them. So one of the most famous examples of those is a Fibonacci sequence. So I'll write that out here. So the Fibonacci sequence. So this is pretty much what seems like random, but it does have a pattern. So it starts with 1. The next one is 1 as well. And then we would have 2, 3, 5, 8, and so on. So what would this be? So this does not match an arithmetic sequence or geometric sequence, since there is no common factor or no common difference. But still, this sequence can still go on. So this sequence does not rely on either of those. Instead, it relies on a special pattern, which is the sum of the past two terms. So this here, for the first two, those are just 1 and 1, and then we still have 2, so 1 plus 1 equals 2, and then we have the fourth term, and we find that by 1 plus 2, which equals 3, and then so on and so forth. So we have those terms here. So say you wanted to find the next the next term, which in this case would be finding the seventh term. So we would find that by adding 5 plus 8. Here, I'll just put this here, seventh term. 5 plus 8, which is the past two terms, and that is just 14. So this does sort of act like a geometric sequence, since it grows sort of exponentially, but not with a fixed common factor, but it does sort of grow way faster than an arithmetic sequence. And I wouldn't say it would be slower than a geometric sequence, but it is faster than some and slower than some as well. So this would just be something sort of like fun to do, and just finding the next terms after that. If you wanted to find the eighth term, you would have to add in 14, which just equals 22, and then we would still go on so forth and all the way to the infinite term. So, but yeah, so this Fibonacci sequence would not classify as arithmetic or geometric sequences, but it's just like sort of by itself, since it does not classify as any of those criteria. So let's try some problems regarding this. And so for the first one, it asks is 1, 1, 2, 3, 5, 8 an arithmetic sequence. So if you recognize this, then well, you've been listening. So this is the Fibonacci sequence, and this here does not classify as an arithmetic sequence or a geometric sequence for the matter, since it does not have a common difference or a common factor. And this here, it would be a no as the answer, since it does not have a common difference, which is what it's asking for pretty much. Alright, let's do the second one, which asks, is the Fibonacci sequence geometric? So the Fibonacci sequence is not geometric because it does not have a common factor, as it just relies on the sum of the past two terms for the next term. So no, it would not be geometric. Alright, so let's move on to the third one, which asks, is 2, 8, 16, and 32, and so on a geometric sequence? So we would have to see if if there's a common difference here. So 8 divided by 2, that's 4. 16 divided by 8, that would be 2, and right away we can see there that it is not a geometric sequence. Instead, to make it a geometric sequence, we could have changed the first term to 4, but instead right now it's 2, so that means it is not a geometric sequence. Alright, let's do the fourth one, which asks which one is a geometric sequence. Alright, so the first one is 1, 2, 3, 4. So that one does not have a common factor, instead it has a common difference, which is 1 in that case, and so that would not classify as a geometric sequence. Alright, let's move on to, let's see the second choice, which is 3, 9, 27, and 81, and so on. So that one we would have to find 9 divided by 3, which is 3, 27 divided by 9, which is 3 as well, and then we have to do 81 divided by 27, which also equals 3. So that means that the common difference for here, for that sequence, is 3. And since it common factor I meant. So since it does have a common factor, that would mean that it is a geometric sequence. So this one will be yes. This one is a geometric sequence, and yes, there is a choice as well. Alright, let's do the fifth one, which asks which one is a geometric sequence. So in this one we have 2, 6, 18, 54 for the first one. So this one we have 6 divided by 2, which is 3, 18 divided by 6, which is also 3, and 54 divided by 18, which is yet another 3. So that means that this, since it does have a common factor, it would have a, so it would just be, yes, this one is a, well, actually, I just read the problem wrong, which does happen sometimes, so, no, this one is not it. Instead, this one is a geometric sequence, and this question asks for an arithmetic sequence. So I'm sorry about that. So this one we just did is a geometric sequence. So then that only leaves a second choice, which asks, which is -1, 0, 1, 2, and so on. So this one we would have to find the common difference if it does have one. This one, it appears that it has a common difference of 1, since every term is exactly 1 greater than the last one. So yes, this one is right. Not the first one. Okay, so let's move on to the sixth one, which asks what is the fourth term for 1, 2, 4. So in this one we can see it is a geometric sequence, since it has a common difference, a common factor of 2. Since 2 divided by 1 equals 2, and 4 divided by 2 equals 2 as well. So that means it will have a common difference of 2. So now it's asking for the fourth term. So we have 1, 2, 4, and so on. So this here, we just have the last term, which is n minus 1. This just equals that. And then it'll just times the common factor, which in this case we just said was 2. So 4 times 2 would just be our fourth term. That equals 8, which is the fourth term. Alright, and that would just be our answer. So that's 8. Alright, and that would also end our lesson for today. So thanks for watching. Please subscribe. Thank you. And also, if you have any questions, feel free to leave those into the comment section. And thank you.